मैक्सिमम और मिनिमम वाला है जो हम यूज करते आ रहे हैं, बेस्ट प्रोडक्ट और द करंट प्रोडक्ट, तो वो भी इंशाल्लाह इफेक्टिव होना चाहिए। ठीक है, तो अभी हम ऐसा करते हैं कि पहले हम रिविजिट करते हैं कल वाले क्वेश्चन को, जो कि मैं सही तरीके से मैं एक्सप्लेन नहीं कर पाया उस, और पहले उस कोड को, उस पार्ट को जो थोड़ा कंफ्यूजन था उसको समझेंगे, एंड देन वील मूव टू द रिवर्स लिंक लिस्ट। ठीक है, तो फिर आज के दिन हमारे अरेज के जितने भी क्वेश्चन है शीट के अंदर वो कवर अप हो जाएंगे, इंक्लूडिंग दिस, इफ यू आर एबल टू अटेम्प्ट दिस ऑन यूज बाय योरसेल्फ। अदरवाइज ये वाला क्वेश्चन प्लान्ड है, शीट के अंदर मेंशन हुआ है। लेट मी क्लियर दिस अप, जस्ट अ सेकेंड। ओके, तो यहाँ पे मैंने उसको लिखा है एक्सप्लेन द जनरल आइडिया, मैंने आपको इंट्यूशन बता दिया, एंड नीड टू एक्सप्लेन आइडिया इन फुल। तो स्टेप बाय स्टेप अगर आपको वो आइडिया समझ आता है ठीक है, नहीं है तो कोई और बंदा उसको प्रिपेयर करके एक्सप्लेन कर दे किसी भी सेशन में। ठीक है, तो चले, बिस्मिल्लाह रहमान रहीम। लेट्स रिविजिट द क्वेश्चन दैट वी kind of I just kind of like dropped out and wasn't able to explain really well. It was out of fatigue as well because I've been spending a lot of time doing lead code and full-time jobs, so it's a bit hard for me. But anyways, that's in the past. I'm not going to rewrite the code. All I'm going to do is explain to you the general idea of what the question was for those who are not familiar with this question, and then we'll move into the line by line code implementation, how it accomplishes that goal. Okay. So before we start, the time complexity my solution was able to accomplish is O of n log n. Reason being because I'm using sorting 2 times, but this is not any kind of nested sorting or sorting upon sorting, any manual sorting. I'm using inbuilt functions, and these two are independent sorting. So the worst time complexity you will see is O of n log n. Okay. This is the time complexity that a sorting function will give you. Okay. Now, the question was given an integer array nums and an integer k, return the k most frequent elements. This is the key to understanding this question. What does this mean? Return the k most frequent elements. If you're given an array, you need to find two distinct elements. Distinct means two different elements that are easily distinguishable, that have appeared the most number of time as compared to all the other elements in the array. In this case, it's very obvious. You have one appearing thrice and two appearing twice and three appearing only once in that entire array. In that case, it is very easy to understand that one and two are the two most frequently occurring elements. Now, this is talking about the count of elements, not the frequency. Frequency is something you need to find and determine. Okay, then yesterday we discussed what if we use a hash map to record the frequency. But the problem is if you use a hash map and you map the count according to the hash map, you have no way to find out which element has the highest frequency and which element has the next highest frequency. Since this is a sorted array, it makes sense we can get the first one and second one. But at the same time, if you have a large array, even then it's a little bit difficult to find what that highest, because we cannot sort the hash map. Okay, we're using key value pairs. In that case, we discarded the idea of using hash maps at all, and the approach I took was using multiple lists and grouping within the lists, and mapping the count to the actual number that one is appearing thrice and putting it inside an integer array and then grouping them inside array list, which I'm going to come to and try to explain that a little bit in a bit now. Okay, so by grouping this, we sort it again and then return the numbers with the highest count. Okay, so how we're going to do that is something we're going to arrive at in a while. Okay. So if you're seeing this statement here is a pretty generic statement, it's usually used to make sure that our inputs are actually valid. If inputs are not valid, excuse me, if the integer array itself is null, there's no value to it, or the length is 0, there's nothing inside it, or if your k, which is the count, of the numbers that you need to return, if that is equal to less than or equal to 0, if it's in negatives or equal to 0, now in that case it becomes invalid. But most likely they're not going to give you invalid inputs. It's going to be valid input. But k is something you need to understand because it's going to be an important point to consider when we are going to sort the groups. Now the k is in the range of 1 to the number of unique elements in the array. So in 1, 1, 1, 2, 2, 3, the total number of unique elements are 1, 2, 3, and the max total distinct elements are 3. They are not 4. Okay. So if k is asking you for 4, this is an invalid request. The best you can return is only 3 distinct elements that have appeared the most number of times. Okay. So if someone is saying, no, give me k is equal to -1 or -100 or so on and so forth, or for example, give me k is equal to 0, that's basically saying don't give me anything. But what if I have all? Then in that case, I don't return anything. I just return an empty array. Okay. That being said, we can move forward with, I decided to sort my array so it will be easier for me to iterate upon them, iterate upon the elements, because in this case, I already have a sorted array. So I don't have to think much about checking if I have a duplicate. So I count it. If I don't have a duplicate, I just keep moving forward, right? But in this case, where I have where I have all these numbers jumbled up, even though they are only total three, 1, 2, and 3 distinct elements, but they're jumbled up in a way that if I just simply iterate over it, the iterations may become very complex and it will be harder for me to write other operations. So sorting is something that I threw myself upon. So sorting worked out pretty good for me because it retains us, it confines us to the O of n log n, and we don't have to worry about much. At least this array will be sorted in 1, 1, 1, 1, 1, 1, 1. So there are four ones and there are two threes and there are like 1, 2, 3, 4, four twos. Okay. So if I sort them, of course, I twos are going to come before three, and then we're going to have threes here. Okay. Now the technique I used for iteration was basically iterating upon each and every element. And as I move forward, we'll take this example. It's easy to understand. As I move forward, I check that the element at my current index is that equal to the last index. And if it is equal to the last index, which is I minus 1, in that case, I can increment my count saying that, yes, I have found a number that has a frequency more than 1. If not, I can simply just move forward. And once I arrive at a different number where the frequency is not able to continue itself, and then in that case, what I do is I simply take the count and I take the distinct element. I take the distinct element, put it inside a separate array, and name that array value, and use another array and put my count inside of that. Okay. And I continue like this until I arrive at the second last. Now, usually I'll be left out with the last element because I don't have anything to compare for this one with the last one. So I'll just take the last distinct element and I'll just map and add it to the value and add its count, which will be 1. Now, keep in mind that every time I'm updating the count and I arrive at a different distinct element, in that case, I've already counted for all these three. So if my count is currently equal to 3, I can save this count somewhere. In our case, we're saving it inside the array and reset our count to 1 so we can count afresh. Okay. So that's how we're going to iterate over it. And finally, the last element will always be checked and be added to the values array. It will be appended to it, and the count will be count of 1 will be appended in the second array. Okay. All right. So, um, all right. So once I've sorted this, this is just to keep a measure of the length of the array so I can control my iteration, the flow of my iterations, okay? And this list integer, this list right here is of type integer, storing values and counts, okay? And this right here is count equal to 1. So why I'm initializing count to 1 and not 0 is the reason being is that at least I'll have one instance of an element that I'll have to start with. And upon that, I'll keep iterating. So this just makes things a little bit simpler. All right, now let's move into the next step where I have for loop. For loop is doing the exact same thing I just told you diagrammatically. And integer I equal to 1, starting with 1 and keeping count as 1. And I am just adding the count to it and going until, okay, so here, why I'm not if I need to start with 0, I need to make sure its I is less than or equal to n. But since I'm starting with 1, I'm keeping I less than n. I hope you guys understand this concept. It's pretty basic. And I keep checking if the current nums of I is equal to the nums of I minus 1. If it is, I keep incrementing count. If it is not, in that case, what I do is whatever the element is at the I minus 1, because I minus 1 would mean if I have arrived here, in that case, I need to append I minus 1, which is 1 right here, which is the one distinct element into the values array, values list, sorry. And then I add the count that I had stored previously. In this case, I had stored 3. So the count up until here is 3. I add the count to list of integers inside this count and reset my count equal to 1. Okay. I continue doing this until I've explored the entire array, which is being represented by this n right here. And what is n? N is nums of length. Okay. Starting by 1, do length of nums of length. If I had to start with 0, then it would be n minus, this would be n minus 1, which would be equal to nums of length minus 1. Okay, that's what it would be equal to. Okay, now once I have added to all the values and all their counts inside two lists, what's the next thing I do is I group them inside an array list. Okay, okay, first of all, I'm going to find out what were the values storing? The values were storing the distinct elements like 1, 2, and 3. Because every time I'm finding a separate element, for example, 2, I'm only adding one instance of the duplicates that I actually traveled through, right? So eventually, when I am done with my iterations, I'll have distinct elements being added, right? Mapped to their counts. So first thing is that I had sorted them. Second is I iterated from 0 to the end of the array. So I can expect from the smallest number to the highest number, I was able to map all the numbers. And the counts are equally mapped to them or parallelly mapped to them to the individual numbers. Okay. So here the count of 1 was 3 and count of 2 is 2 and count of 3 is 1. So in that case, if I were to group them inside another array by running loop over them, I can group them in form of counts and values. Let's get into how we're doing that. Look at this might be a little tricky here. So okay, first I need to iterate over the group count. What is group count? Is the length of the array of values, the distinct elements. So I'm iterating over the elements and I'm mapping their, okay. If you pay attention here, you're going to see an array list, okay? Inside array list, we are expecting elements, or you can say the data types of integer arrays. So we have a list of arrays. We have a list of arrays, okay? In each integer array, what I'm doing is, first thing I'm doing is I'm taking the count, counts.getI counts.getI, right? This is a array list function, so we can just get the value at the ith index. Remember, I said in the values, I have 1, 2, 3, and parallelly mapped to their correct count, which is 3, 2, and 1. This is my values array list, and this is my, what is this? This is my count list, okay? So if I am iterating with respect to I, just like right here, starting with 0. So at the 0th index in value, I have 1. At the 0th index in count list, I have 3. So if I map them, 1 and 3, if I map them such that the count goes first and the value goes second, am I mapping inside this integer array in the correct order? Yes, right? Because they're parallelly mapped. So the indexes are same. This was the idea that I was trying to convey yesterday, is that we need a way where we can map the order of the indices to the count. And there has to be some sort of connection because we cannot sort using hash map. So the very first idea was that I was using multiple arrays to keep the count, to keep the index, and then somehow based upon the count, I rearrange them into descending order. And if I am swapping them into descending order, I need to make sure I'm using exact same operations to rearrange the indices inside the index array. And then I just return the indices, the first three indices. But the same idea was simplified by just using list and mapping the value to their correct count, okay? Because we have already sorted these arrays. So I hope this is easy enough to understand. If not, please raise your hand and ask for clarification, okay? All right, so I think we can move forward from here. Unless you guys have any questions, please feel free to raise your hand again. Okay, so counts.getI and values.getI, I'm mapping them. I'm creating a list of multiple integer arrays where I have count 3 and there's 1 and then there's 2 and 2 and so on and so forth. And then I have 1 and 3. Count value, and count value, okay? Now, if I have a way to rearrange these elements, if I have a way to rearrange these integer arrays in a way where the number with the highest count appears at the first index, and then it is followed by the smaller and smaller count arrays, can I say yes, I have sorted the numbers based upon their counts from highest to lowest, determining what is the most frequently appearing elements or most frequently appearing integers? Yes. Okay, so for that, we use an inbuilt function in Java, which is integer.compare. It uses string sort, similar O of n log n. That is the worst case. Best case, it can do of n if the array is sorted. If it is not sorted, if this is not already sorted, then the worst case, it hits this O of n log n. I'm going to explain to you how it actually works. It's going to be pretty interesting for you guys. Okay, so imagine if I have this list of these groups that are representing the count and value in a way where I have, for example, um, 2, 2, and 3, 1, okay, and 1, 3. Count, count, count. Value, value, and value. Okay. If I can compare this count with this count, and if I can determine that 3 is greater than 2, I should be able to swap this integer array as an element with this one, and I should be able to put this here. And then I need to compare this that I've moved here with this one as well. What if this is greater, right? Then I need to swap it. And then I need to, since I've already compared this one with this one, now the only last possibility left is comparing this one with this one, okay? So maybe this will take the second position. So in that case, we use this integer.compare. We use integer.compare. It rearranges them in a descending order. How? Okay, let's look at it piece by piece. Okay, this is a lambda function. This is a shorter way to write a function, right? You don't have to write the entire implementation with your access modifiers and your parameters and all of these things, right? So what you do is, first of all, you take these groups. What is your groups? This is the list of your integers mapping your counts to your values correctly. Okay, so this part is done. So we are going to focus on this now. We sort them by introducing two variables a and b such that we compare the first indices, just like I said, the counts 3 and 2, 1. This is the count. We compare these counts, and whichever one is greater, we return that as the first index. We swap them in this way. But how is it exactly working? Why are we seeing A and B here and B and A here? If A and B, for A and B, if A is greater than B, then in that case, this function right here returns a negative number. And if B is greater than A, it returns a positive number. Somehow underneath the Java engine, what it does is it looks at this implementation and then swaps them. So if B is greater than A, B will take the first position and A will take the second position. Otherwise, B will move to the second, and A will move to the first position, right? So we reverse the order. This will make sure that we're returning positive number, and this will move the B to the first index. If it is not, then it's going to move A to the first order. Okay, so this still you still may not be able to get the entire implementation unless you actually really look into it. But this is what I got from what I've read, and this does a pretty good job rearranging all the elements by their count in a descending order. Okay. All right. Moving forward, we arrive at this part. Remember, I told you about K, that if K is greater than the total number of distinct elements that are possible inside that array, in that case, the best you can do is whatever you have, right? Whatever you've been able to figure out. Let's say in that case, they're saying, give me K is equal to 4. Give me 4 distinct elements that have appeared the most number of times. But I only have 3, right? So whatever I have, can I count this? Yes, I have the count for distinct elements. In that case, this is the best I can return. So math.min, what it tells you is the between k and groups.size. If they're equal, then there's not a problem. If k is greater than the groups.size, then groups.size is the best best number of distinct elements that I can give you. What is group.size? We created a list. This was mapping the distinct elements with their counts, right? So on and so forth. So you only have inside the groups, you only have the distinct values, right? You have distinct values. So in that case, you need to consider K, the number of distinct elements, as the groups dot size, what you were able to figure out through your code. Okay, now that I've determined the size of my K, the correct size of my K, this is just a make sure we are not, this kind of like a exception handling kind of thing, right? We initialize a new array with the size of K because we need to return the K number of elements, okay? Sorry, no one mentioned it may be a little bit hard to read. But yeah, K would be the size of this integer array, okay? And then what do we do? What do we do next? We arrive here and we start with another loop until K. So let's say if the K is equal to 2, we're going to run 2 loops, or what? We're going to take these groups, okay? For example, I have, let's say, 1 has appeared, value of 1 has appeared 3 times, okay? And value of 2 has appeared how many times? 2 times. Okay, what if I'm just iterating over this? In that case, what I'll do is I'll do the name of this list is groups, right? I'll say groups.getI. I is equal to 0, okay? What is the zeroth element? This is the zeroth element, the sub-array or sub-integer array. And upon the 0, I is equal to 0, get me the first index. What are we trying to return? The count? No, we're trying to return value. So within this integer array, we have another index, 0 and 1. So when we return 1, what this I will make sure, once I gets updated to 1, it will again look for the first element. And that's how we will map these values to this result of I and finally return our result. Okay, the time complexity for the entire solution is pretty simple. Okay, you're seeing sort functions on 2 ends. So let's go step by step so it's easy to break it down and understand. This is just O of 1, okay? This just gets checked one time. No need to worry about it. This right here is a sort function. So O of n log n. This is the worst complexity. Again, O of 1, so we don't really consider it in our scenario. O of 1, O of 1, nothing to worry about. Right here, this is O of n. Why? Because we're running loop all the way to the end of the array. So this is O of n and plus O of n log n from the sorting function, from the previous sorting function, okay? And then we come down to the, let's move down to the, again, this only happens O of n times, okay? So this entire solution, this entire block right here that you see is O of n. Then we come down to values.add nums of n minus 1, again of 1, only one time we just look for the last element. Counts.add, we add the count of 1, again we ignore this. O of 1, don't need to really worry about this. This right here that we're mapping, this is again of n because we are running loop to the length of array. You can actually call it, um, I think this is going to depend on the size of the number of the distinct elements, right? So if your number of distinct elements are m, right? So you can say this is O of m, right? It's not O of n. This is your O of n because this is the actual size of the array. Then we're creating two different arrays, which is values and counts. So whatever the values, let's say 1, 2, 3. This can be different, right? We don't know what the value could be. So of m, and for this block right here, this O of m, I'll add that O of m. And then again, we have a sorting function. So O of n log n. This sorting was through compare. And again, we have O of 1, O of 1. And then this part right here is again a loop that's running over the size of k. So this is O of k, not O of n, because we're not running it on the entire array. We're just running over the number of times the k is. So in amongst all of this, what is the worst time complexity is no doubt offline login. So we just do not even consider all of this. So time complexity for this offline login. Now, what they're seeking is a solution that is better than offline login, right? And I believe how that can be accomplished is by using queues or some other data structures. We can probably use the divide and conquer, which I think we've used probably in this one. Bucket sort, it's a new concept. I was trying to understand this. And that's where I actually got the inspiration about using two arrays, to ones to map the index and ones to map the count, and then create some sort of connection between them. All right, so this was the explanation for this entire solution for this question. I'm sure there are better solutions using heap that I think one of our fellows who is very regular, he explained yesterday, and he has shared the solution in the channel. Um, Now, if you guys have any questions, please go ahead. If not, I can quickly try to finish the reverse linked list, and then we can move to. I'm trying to save up some time for you guys. So you guys, if you want to present something, you guys should be able to. All right, go ahead. You guys have. I can give like 3 minutes to ask your queries or anything like that, since there are not many of us.
So yesterday I started a question, wasn't able to complete it. Do you want me to complete that, or do you want to continue either way works?
Okay, I'll take like 10 minutes to finish this. It's not going to take much time, and then I'll give it to you. Is that
All
fine?
right.
Okay.
Yeah, it works.
Okay. Thank you. Actually, you covered up for me yesterday. I wasn't feeling well, so thank you for that. Yeah, I dropped
Yeah,
out.
no problem.
I ran away from the battlefield.
It's all right.
All right. Yeah, sometimes with your full-time job, you don't even know, and your mental health starts
Yeah,
getting
you're
hit.
doing it pretty late and doing it consistently. I think yeah,
Yeah.
it's very commendable.
Thank you. Thank you again. Anyways, let's move to this. And this is a new topic for me, linked list. I've seen it before happening. I may actually end up using hold on, how do I shorten this? Um, I may end up actually referring to my existing solution just to save time. But yeah, I'll do my best to try to explain the approach that we're going to take on this. Um, so Okay, linked lists. I'm pretty sure you guys have been introduced to this concept before. Linked lists are basically your storing your data in such a way where in its one memory space you have your data, and then you have another storage which has address for the next data, right? So you may have completely random memory locations, but as long as this piece of data has some extra data that records the address for this data, you have a linked list. As long as this is pointing to nothing, right? And then you can increase the size of your linked list. This is your linked list, right? You can iterate over it as a list, but by using addresses indices instead of indices. Now, what do we normally do in an array? You have like 2, 4, 5, for example, and then these are segregated in contiguous memory location like 0, 1, 2, one after another. But for linked list, that constraint has been taken away, right? So in that case, what you do is uh, you deal with nodes, right? Nodes are basically memory spaces where your data is, right? For example, here you have an integer 1 and then you have integer 2. So these are at two different memory locations within your within your storage, right? But as long as you are able to get address for this memory location, data from this memory location here, and this address can be used as a pointer to this one, and then it can have another address and point to another one. This is called a singly linked list, which is only linked in one direction. You can only go from 1 to 3 until you hit null value. Okay, so it has to point to null for the linked list to properly end. And the first element is called head. We have to have a pointer to the first element, and that would be your head. Okay, so from head to tail, tail appears at the where you arrive at null. This is single linked list from one end to another. For the doubly linked list, what you have is each node is pointing back to the original node that was calling it. Okay, so this is called a doubly linked list. Okay, I don't know where the null is. I think null still has to be there for this to end. But for now, the scope of this problem is to deal with a singly linked list. Okay, we'll read the problem. We'll try to quickly solve it. Alrighty, so okay, what's happening to my pen? All right. Given the head of a singly linked list, reverse the list and return the reverse list. So you have been given a linked list where you have a head. This is the head, okay? And this is your tail, and this tail is pointing to null. Okay, they're not showing it, but that's how it is. Given the head of a single linked list, reverse the list and return the reverse list. You need to reverse this list where 5 starts pointing to 4, 4 starts pointing to 3, 3 starts pointing to 2, 2 starts pointing to 1, and 1 starts pointing to null. Now in this case, your 5 becomes the head, and 1 becomes the tail, and tail is pointing to null. Okay? All right, let's read some constraints that we have. They've given us an input with head pointing to this linked list starting with 1 to 5. This is where your head will be initially, and then when it's reversed, the linked list reversed, your head will fall at 5. And just like in this case, your 1 and 2 is now reversed to 2 pointing to 1, 1 pointing to 2, and 2 pointing to 1. Head, if there's nothing, of course, return nothing. Constraints are the number of nodes in the list is range 0 to 5,000. So each of these are nodes. These are called nodes, right? So nodes have the addresses that are used as the pointer to the next node and so on and so forth. And in this condition, they're saying the value inside this 4, 3, 2, 1, 5, they can be a negative 5,000 number and a positive 5,000 number. Okay, so how do we reverse this? Now, I want you guys to pay attention because this may be a little tricky. I will use some pointers, and what I will do is I'll run my pointers, okay? Um, Basically, if you're familiar with it, I'll change the regime, right? I'll send my agents, I'll change the regime and linked list country. Okay, keep this in mind. It's a pun, but whatever. Okay, so this is my head currently. What if I say my current pointer is equal to head? Okay, makes sense, right? And then I initialize a previous that is pointing to null. Okay, I'm introducing list nodes. This is called a list node. Okay, this is a list node. So if I introduce a node that is pointing to head, and then I introduce a previous equal that is null, and then I introduce another pointer that is initially null. Okay, The way I'm going to use that is initially I need to see the previous node is pointing to null. Okay, previous node is pointing to null. It's a standalone node. What I'll do is I'll make this node point to previous, and previous is pointing to null, and then I'll set previous, the value of previous, to 1. It's same as saying I have an empty node. My empty node is pointing to null. Okay, I have a node that is part of entire list, and somewhere it's pointing to null. I'll take this node, I'll make it point to this node, and this node is pointing to null, and then I'll just reset the value of this node as 1. And since this is not pointing to anyone, right, it's of course it's pointing to this one, but now I will detach this, right, and move my head. Currently my head is here. Okay, I'll move my head to the next one. So now this becomes a standalone node with nothing, right? Standalone node with nothing. So this gets removed from memory. So now what do I have? What am I left with? I'm left with, come on, give me the pen. Get the scissors. Okay, what I'm left with is this is pointing to null. Okay, now this has become the node that's pointing to null. And now my head has been updated to 2. So now my linked list looks like 2, 3, 4, 5. Okay, and now my new head is 2. I keep doing this. Okay, now next thing actually. Now I need to point this to this node, okay, and update my head to 3. Okay, now this is not pointing to anything. In fact, 3 is pointing to 4 and 5 now, right? So now 2 is pointing to 1, right? 2 is pointing to 1, and then I keep moving forward until I arrive at null pointer here. And that way, this linked list becomes reversed like this. So 5, 4, 3, 2, 1, and null. And that's how my linked list is reversed. But how do I do that is I introduce, I'll have to introduce 3 pointers, okay? And let me wrap this up in like 2-3 minutes so you guys have time as well. Okay. First of all, what I'm going to do is this is already had, we know. I'm going to assign it a current pointer, okay? And this current pointer, this is a type of list, this is type of a node as well, okay? My previous is pointing to null, okay? And my next will be, next node will be like this. So I can say current dot next, that the next to this current one is equal to next, okay? All right, but initially this one will be null as well. Okay, once I arrive here, I update my next to current.next so I can store this. Okay, and then I'll point my current to previous. Okay, which means this pointer right here, this represents current.next. What if I say current.next is equal to previous? Okay, in that case, if I say current.next equal to previous, don't want to confuse you. I hate this annotator. My next is equal to current.next. Next is just to save the next spot before I delete this from the list. Okay, that's all it does. Current.next, I set it to previous because I want to point 1 to previous. Previous is pointing to null. Good. Previous is an empty, what you call it? An empty node. The next thing I need to do is assign the value of current to previous. So that becomes my node. And then it's pointing to null. Okay. So then I do is previous, update the value of the previous node that is empty currently to the value of current. Okay. And the current one, the current that's right here, I'm just updated the previous, not the current. Current should move to the next node. because now I have pointed that to null. This has become disconnected from the list. Now I can update my current to the next node. And updating the current would mean I have updated my head. Okay, I can also name current as head. So I will do current is equal to next. And I'll keep repeating this. I'll keep updating my next pointer to seek out the next one and take the current one pointer to the previous one. Previous one in that case will be one, right? Not null. And then I'll keep moving until I arrive at the null pointer right here. In that case, I stop. Okay. So I'll just quickly write logic for this. And then we can ask for clarifications later on. Okay. First of all, what I do is of type list node, I define a pointer current that is initially will be equal to head, and then list node, I'll introduce a previous that is equal to null value. Okay. It's not pointing to anything right now, and that's what we need. Exactly, that's what's needed. Next one will be equal to null. What this will do is this will keep track of the newer. Actually, I think we should keep the next at current. At least should start somewhere. Maybe it doesn't matter, whatever you do. Current is not equal to null. While my current pointer does not hit null, what I keep doing is I do next equal to current dot next. Okay. Wherever am I right now, the next node from that. If I'm at one, if I'm at one, the current dot next will be two. If I'm at two, current dot next will be three. Okay. And then I do current dot next, which means that current dot next for this one current, the next should be the previous one that I have introduced as the null node, this one. Current dot next is equal to previous. And then I take the previous node that is currently empty. I update that with the actual value of the current, which is 1. And I keep repeating this process. Okay. Now that I have mapped to the correct node and I have the previous one, the previous one has been updated to previous node has been updated to 1, pointing to null. Now my current is here, so current needs to move here. So this becomes invalid or out of the list. Okay. Now how do current comes here? I had already stored that as next before I did all this operation right here, right? And I just need to point current to next, and that should take care of moving my head to the right node. Current is equal to next. Okay. And once this loops end, once this loop ends, uh, I'll return the uh, previous one. Okay. Why not current? Because current has resulted in arriving at null, and the previous will finally, this will be 5 will be the final one that will be pointed to previous at this point. Okay. So I can return previous. We're going to run this, and the time complexity should be O of n. O of n is the complexity. Okay, over to you guys. If you want to share, I know there's not much time, but if you can quickly go over your solution, Hadi.
Basically, it's a recursion plus memoization, which is a dynamic programming problem.
Okay.
So I was thinking of actually showing you the recursive call stack, because with the recursion, can you see my screen? Let me see.
Yes.
I have got it. Let me check. Was climbing stairs problem. So we had actually created the recursion part of the problem, but one thing that we needed to add, because what we were discussing yesterday, is whenever we have distinct ways, we have to draw some kind of a decision tree. That we did draw, and to go through the decision tree, we have to define a function that recursively calls a recursive case or the recursive relation,
Mm-hmm.
uh, which is n minus one step, which it says that either you take one step or you take two steps, so it's either n minus one or n minus two. And what I had done. Let me see. So this is the basic recursion. Let's say with the input 4, if I visualize this, then I've got 24 steps. So it keeps on going. I'll just do it a bit faster here. So this is the first time it goes to n minus 1. It checks that, when the input is 4, it calls that function, and then it keeps on going. So going each time n minus 1, it's reducing n by 1 until it reaches the base case. Oh, let me go back. Reaches the base case where n is smaller than or equal to 2 and returns n value. So this function would now have a value 2, and then it would move on to this function and recursively call it. Let me see. And then this is going to be, since the parent has 4, it's going to be 4 minus 1, which is going to return 2. And then it
So
returns a
basically
value 3
fixing
plus 2.
for
So
one
this is
step.
basically, yeah. So it basically calculates the total number of combinations, or the, uh, total number of combination of steps, or in this case, when n is equal to 3, there are 3 possibilities. But the problem with this solution would be, when I submit